Gas law guys. Gas laws for changing conditions. Boyles, Charles, Lussacs, and Avogadros are used most for changing conditions, even though the ideal gas law can be manipulated for changing conditions also. These four are the most used for changing conditions. Boyles, Charles, Lussacs, Avogadros. The variables of gases involved: pressure, volume, number of moles, and the temperature in Kelvin. And the temperature in Kelvin is exceedingly important. Please remember that anytime you use a gas law, you have to convert your Celsius to Kelvin. Right? And there's no little degree sign with the kelvins. That's first year chemistry stuff. Boyle's was first. His law is comparing volume and pressure, holding temperature and the number of gas moles at a constant. And what Mr. Boyle found out was that pressure and volume are inversely related. They're the only one that is opposite to. The rest of them are all directly related. He found a formula that you could calculate the volume of the gas after changing its pressure. So here's condition set number 1, condition set number 2. This is 4 variables. You are holding temperature and N constant. That's why they're not in this formula. And it's real easy to do. One quick note here. These don't have to be specific units. You don't have to have it all in atmosphere, but you have to have the same units. Alright, I have no picture for Charles's law. He found a relationship between temperature and volume. His relationship is that temperature and volume are directly related or directly proportional. One goes up, the other goes up. He held pressure and the number of moles constant. His calculation for a changing condition, again 4 variables, given 3, you find the 4th. And again, temperature in kelvins, remember that. And when you're thinking of this, think of a hot air balloon. Because how does a hot air balloon work? It's hot air. The minute they pull that string and turn the fire on, the balloon will expand, because as the temperature goes up, the volume goes up. So you got a hot air balloon that works that way. Monsieur Lussac's law was a relationship between pressure and temperature, holding volume and N constant. And again, pressure and temperature have a direct relationship. One goes up, the other goes up. His computation relates pressure and temperature. Again, 4 variables. You'll notice N, number of moles, isn't in play yet. That will be Avogadro's. 4 variables, 3 given in the problem. You find the 4th one. It's a direct relationship. Again, temperature must be in kelvins. And, for example, which I'd hate for you to try at home, think about an exploding air canister in a fire pit. You put aerosol hairspray or anything else that's an aerosol, that's an inflexible volume that's in a can. You put that in the fire pit and it starts heating up. Those gas particles are going to move faster and faster and faster. The pressure is going to increase in that can until it goes boom. So you have a exploding canister based on the gas laws. Avogadro's law is the only one that related a relationship between number of moles and volume. And of course the relationship between N and V is a direct relationship. And his calculation again has 4 variables. And again, a direct relationship. Let's see. Well, this is very simple. Think about filling up a helium balloon. How do you get a balloon to get bigger and bigger and bigger? You put more air into it. In other words, the more moles of gas or air you put into a balloon, the larger the volume gets.